So hello everyone, welcome to our new video. In the previous video I have discussed with you about the implementation of graph using adjacency list for unweighted, directed and undirected graphs. So in today's video I am going to cover that how we can implement a graph using adjacency list for weighted graphs. Okay. So here I have the same program that I did in the previous video. Okay. So I am taking the same example. Here everything, whatever the header files we have to import, everything is the same. We have the graph class here also, we have the graph class here also. Then after that, here also I have an unordered map, here also I have an unordered map. Now what is the difference here? In this one, here we had an integer and then a list of integers, right? But in this case we have an integer and after that we have a list of pair of two integers. Here we just had a list of integers, but here we have a list of pair of integers. Here we had single integers, but here we have pair of two integers in that entire list. Okay. Now those two, now in the pair, what are they representing? The first integer, it is representing to the node that where we are going to, and the second integer is representing the weight, that what is the weight on that edge. Okay. Then here in this void add edge function I had three parameters, int u, v and boolean direction. It means the source node, the destination node and then the direction. But here we have another extra parameter. What it is? That is the weight here, that how much is the weight on that particular edge. Okay. Then everything we have here is same, everything remains same here. Now while adding any new element, here we had previously written that whatever it is, the list, adjacency list at the index u dot pushback v, but here pushback, now here we are sending the pair of two numbers which is v comma weight. That's it. Okay. Then similarly for if it is a undirected edge, then it is obvious that we have to do it for the reverse one also. If it is 0 to 1, then also we have to do it for 1 to 0 and the weight is going to remain the same. So here also we are doing the same thing, just we have replaced here u and v. That's it. Dot pushback u comma weight. It will be storing the exact pair of the destination node along with the weight. Okay. Then while printing it, while printing the entire list, so here what do we have? Here we had the pair, there also we have the pair in the node variable. Then after that node first means the key, it is also the same. Now here the difference comes for each and every pair, for each and every destination nodes. Here we just had the destination node, so here I was simply printing neighbor, but here for the neighbor again we have two values. The first one is the destination node and the other one is the weight. So here we have to print brackets so that it is represented there in specific pairs. Then neighbor dot first represents the destination node and neighbor dot second represents the weight of that particular edge. Okay. So now here let us go to the main. In the main, let us look for a directed weighted one. Okay. Here the same examples I have taken, 0 1 1, 1 2 1 and 0 2 1. It is the same here. Okay. Where we all know that the first element in the parameter list, it is the source node, the second parameter it is the destination node, and the last one that we were giving, it was the direction, that it is a directed graph or a undirected graph, that edge is directed edge or undirected edge, right. So that is also the same here, we have represented one because what it is a directed graph. Then here in the third element in the parameter list, 5 8 and 6, these are the weights of those particular edges. Okay. So now let us execute and see how it is going to work. So here now let us draw the graph that is going to be obtained by this data, right, the data that we have given into the program, node 0 1 2. So now where are they going? One is going to 2 0 is going to 1 and 2. What are the weights here? The weights here are 8, 5 and 6. So this is the particular graph. This is done. Okay. Now let's look at the data there, that what we have here. Now if I see this node variable that we have, this node variable, it is representing to what? If I just come and look here, this entire thing, this is a node. This entire thing, this is a node here. Okay. And not only this one is also a entire node. Clear? Now similarly, if I want to check node dot first, now which one is node first? The first element. Now which is the first element? The source nodes here. So if I look here, these values 1 and 0, these are the source nodes. These are node dot first. Then after that, the neighbor. Now this neighbor represents to what? Now this neighbor here represents to these values 2, 8. Okay. Here this entire data 1, 5 and 2, 6. These are the neighbors here. Okay. At every iteration, for 1 this is the only neighbor, for 0 this is the first neighbor and this is the second neighbor here. And after that, what are we printing here? Neighbor dot first and neighbor dot second. So neighbor dot first and neighbor dot second. Second is these values 6, 5, 8. These values are the neighbor dot second. And if you look at neighbor dot first, so neighbor dot first are the nodes here 2, 1 and 2. This and this. Okay. So this is it. This is the implementation for a graph using adjacency list for weighted graphs. Okay. May it be directed or may it be undirected, you know that how it has to be done. If they are directed, then you have to give the inputs here as 1. If they are undirected, then you have to give the inputs here as 0. That's it. Okay. So this is it for today's video. In the next video, I will be showing you that how to write the implementation for a generic graph. Okay. So please stay tuned to our channel to watch the next video. If you have not subscribed to our video yet, then please do subscribe to our video and don't forget to press the bell icon so that you get a notification whenever we are uploading a new video. Now if you have any doubts or any questions in this particular video, you can give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, then please do hit the like button, because that gives us a motivation to record a new video every time. So thank you for today. See you in the next video. Till then, keep learning.